Hi everyone, I am Ranjita. Today we are going to discuss about the network analysis second module, Introduction to Thevenin's theorem. What is mean by this Thevenin's theorem? Thevenin's theorem is a powerful technique used in electrical circuit analysis. It simplifies a complex circuit into an equivalent circuit containing just a voltage source and a resistor. This theorem helps in analyzing and solving a circuit more efficiently. What is the statement of this Thevenin's theorem? In any linear bilateral network with a output terminal A and B shown in a figure A can be converted into a single voltage source VTH in a series with an impedance ZTH as shown in the figure B. The voltage source is called Thevenin's equivalent voltage source and is equal to open circuit voltage measured across the load terminal AB. The ZTH is called the Thevenin's impedance and is equal to a total impedance of the network measured from the load. The terminal by making all the source in the network zero. Proof. Consider the network as shown in a figure using a current division rule or a branch current formula, that's IL is equal to R2 divided by R2 plus R3 plus RL. Next, to find the I, rewrite the current R2. In bracket, we have to mention the R3 plus RL divided by R2 plus R3 plus RL. Then we are going to multiply the R2 within a bracket, that is R2 R3 plus R2 RL divided by R2 plus R3 plus RL. Then from the above network, I is equal to V divided by we know that the current formula I is equal to V by R, and V divided by R1 plus R2 R3 plus R2 RL divided by R2 plus R3 plus RL. Then we are going to cross multiply R1 with the R2 plus R3 plus RL. Then substitute equation 2 in equation 1. That is IL is equal to R2 divided by R2 plus R3 plus RL into V divided by R1 R2 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL divided by R2 plus R3 plus RL. Then we are going to cancel R2 plus R3 plus RL from both the side. Then we get IL is equal to R2 V divided by R1 R2 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL. Verification of equation 3 by Thevenin's theorem. In a step 1, to find the VTH, remove the RL and find the open circuit voltage across the VB. Then VTH is equal to, we already know that the voltage formula V is equal to I into R. Then VTH is equal to V divided by R1 plus R2 into R2. Then in the step 2, we are going to find the RTH, make all the source network zero and measure to resistance of the network and looking in the terminal AB. Then RTH is equal to R3 plus R1 R2 divided by R1 plus R2. Then RTH is equal to R1 R3 plus R3 R2 plus R1 R2 divided by R1 plus R2. Write the in the step 3, write the equivalent circuit load across the AB. Then IL is equal to VTH divided by RTH plus RL. Then we are going to substitute the equation V and RTH. Then we get the IL is equal to VR2 divided by R1 R2 plus R2 R3 plus R1 R2 plus R1 RL plus R2 RL. Similarly, we are going to discuss about the one problem on the basis of Thevenin's theorem. Using a Thevenin's theorem, find the current flowing through a 6-volt resistor for a network has shown. To find the VTH, open circuit voltage has 6 resistor. is load have it remove the 6 resistor and find the open circuit voltage across the AB. Then we have to apply the KVL rule in the first and the second in the circuit. In the first, we are going to apply the KVL, that is loop 1, 4 I1 plus 4 I1 is equal to minus 20 plus 4. The 4 I1 plus 4 I1 is 8 I1 is equal to minus 16. This is I1 is equal to minus 2. Then VTH is equal to VA minus VB. Then VA is equal to VTH and VA is equal to 4 I1 plus 20 minus 5. We getting a minus 8 plus 20 minus 5 is equal to 7 volt. The VA is equal to VTH is equal to 7. In step 2, to find the RTH, make all make all the source in the network is 0. Then RTH is equal to 4 into 4 divided by 4 plus 4 plus 2. Then RTH is equal to 4. Write the Thevenin's equivalent, then I is equal to VTH by RTH into RL. The VTH is 7 and RTH is 4 and the RL is 6. Then we getting a I is equal to 0.7 ampere. The advantages of the Thevenin's theorem. The Thevenin's theorem simplifies the complex circuit, making them easier to analyze and solve. It reduces the number of components in a circuit and reducing the complexity and calculation efforts. The theorem provides an efficient way to find the voltage and current across any load in a circuit. Conclusion. The Thevenin's theorem is available tool in electrical circuit analysis. It allows the complex circuit to be modified into an equivalent circuit containing a voltage source and a resistor. By applying this theorem, the engineers can efficiently analyze the circuit and design a practical system. Thank you, everyone.